This is calculus class, so we're gonna study integral test. So previous section, we did test for divergence. From now on, this lecture, we talk about test for convergence and divergence. First, let's consider this infinity series. So how we know if this series is gonna be convergent to divergent? First, we're gonna expand this series first, guys. Okay. So this one is n equal 1. 1 over 1 square gonna be 1 over 1 square is gonna be 1 plus 1 over 2 square, 1 over 3 square, 1 over 4 square. So first, what do you mean this series, some of this series? So idea is coming from integral. So let's just figure it out what this series is going to be represent. This one is an is 1 over n squared, all right? So I want to change this is a function form, fx gonna be 1 over x squared. So whenever plug in the natural number here, that's coming out n squared. So using this function, first you sketch this function, guys. Now sketch fx 1 over x squared. So 1 over x squared right here. Then we consider improper integral 1 to infinity. So integral 1 over infinity fx dx. What is meant by this improper integral in the graph? Meaning is area below the curve. Okay, 1 to infinity. That's the meaning of improper integral. How related this improper integral to the infinity series? So how related this between the two series and improper integral? Let's just thinking about this one. Now I'm gonna sketch another graph right here, guys. Y equal 1 over x squared. Here is a 1. I'm gonna make rectangle first rectangle. Here is a 2. I'm gonna make a second rectangle below the curve. Here is a 3. I'm gonna make a third rectangle below the graph. 4. Keep going. So first, you're gonna find the first rectangle right here. Base gonna be 1. This is a height. Height gonna be y value when you plug in the 1. That's gonna be f of 1. That's gonna be 1. So this area gonna be 1 times 1 is 1. Second rectangle, this is base is 1. Height gonna be f of 2. 1 over 2 square, that's area gonna be 1 over 2 square. Third rectangle is base gonna be 1. Height gonna be 1 over 3 square, so area gonna be 1 over 3 square. So area of each rectangle below the curve gonna be 1 plus 1 over 2 square plus 1 over 3 square plus 1 over 4 square. Keep going, then we're gonna have infinity series. Left and right side. Let's compare to left to right side, the area below the curve. This left one is area below the curve right here. How to get to this area? We're gonna evaluate improper integral. Right side gonna be area below the curve, but we're talking about area of rectangle. That's each area represent each term of infinity series. Compare two graph, two area, guys. So which one is bigger? So let's just start is a series. Area, total area of each rectangle. So that's gonna be right. That's gonna be represent the series. 1 plus 1 and 2 square, 1 over 3 square, 1 over 4 square. But which area is bigger, guys? Start point to 1. This area is a white area is bigger than sum of each rectangle, so that's less than equal. First one is 1. This first rectangle is not included here, so 1 plus 1. This one is represent each rectangle, area of each rectangle. This area gonna be less than below this curve. So this one is represent the improper integral. Okay, let's calculate the improper integral. We're gonna decide if this infinity series convergent to divergent. Previous slide, this infinity series represent area below each rectangle. This one is 1 plus. Let's calculate this one, guys. Left side, total area of rectangle. So that represents infinity series. Right side, 1 plus. This one is improper integral, area below the curve. So now, guys, let's calculate the improper integral first. Here, right there, let's calculate the integral 1 of infinity, 1 of x squared dx. Let's calculate it. This meaning is what? Here is limit t approach to infinity integral 1 over t x negative 2 dx. Next one, limit t approach to infinity. Antiderivative is negative x negative 1, 1 and t. This one is limit t approach to infinity, negative 1 over x, 1 over t. Limit t approach to infinity. This is negative 1 over t plus 1. T approach to infinity, negative 1 over t going to 0. So this one gonna be 1. Okay, so from here, what do you know here? Summation n equal 1 to infinity 1 over n square infinity series gonna be less or equal 1 plus 1. 1 plus 1, this is gonna be 2. So this infinity series, we don't know the exactly sum of infinity series. At least this is less than or equal to 2. So now our conclusion is summation n equal 1 to infinity 1 over n square is converged. It should be between 0 and 2. So that we have that conclusion, this infinity series convergent. Here's very careful here. This one is gonna be, we don't know the exact value, just we check if this series is convergent to divergent. Let's practice one more time those tasks, guys. This is one of most important series that we call harmonic series right here. That's a harmonic series. This infinity series we call harmonic series. 1 plus, 1.5 plus, 1 over 3 plus, 1 over 4 plus. Previous section we say this is divergent. Why this one is divergent? We're gonna use this graph right here, guys. Looking for a rectangle above the curve this time, guys, above the curve. First rectangle is area gonna be, here is base gonna be 1, guys, base gonna be 1, height gonna be f of 1. This one is 1, because this height is 1. Second is gonna be here, that's value gonna be f of 2, that's the 1 over 2, this is 1 over 2. Third one is this height gonna be f of 3, 1 over 3. This is 1 over 3. But which area is bigger compared to this one, guys? Compare, I sketched the 1 over x graph right here. Y equal 1 over x graph. Integral 1 over infinity 1 over x dx, meaning is area below the curve. This area of this shaded region, area of sum of all the rectangle, which one is bigger? You can clearly see rectangle is above the curve. You can write this one is greater than this area is greater than sum of all the area of this rectangle, that's gonna be 1 plus 1 over 2 plus 1 over 3 plus 1 over 4. So this one is a summation 1 n equal 1 to infinity 1 over n. That's the harmonic series. So let's evaluate this improper integral first. Same thing we did here. Limit t approach to infinity 1 over t 1 over x dx. This one is a limit t approach to infinity ln x 1 over t. Limit t approach to infinity ln t minus ln 1 ln t approach to infinity is going to infinity, which is diverge, meaning is this one is getting increasing. So which meaning is this is getting increasing, meaning is this series is gonna be greater than this area, which meaning is this also increasing, this is diverge. Okay, so harmonic series diverge by using this test. So I'm gonna introduce integral test next slide. What is integral test? Integral test gonna be, we're gonna use improper integral to figure it out if infinity series convergent divergent. Here's very important condition. First, here is a sequence, guys. Look at the sequence right here. Here is a sequence. You have changed the function. Find the function of f of x. You're gonna find what is the function gonna be f of x. So fx have a specific condition right here. Positive, continuous, decreasing function. Then we're gonna calculate the improper integral. Improper integral right here, 1 to infinity fx dx is convergent. This infinity series is gonna be convergent. Improper integral divergent. This series, infinity series, is gonna be divergent. But here's very careful here, guys. Here is warning. This test tells you if infinity series is convergent, divergent, but we don't know exactly sum of infinite series. Let's say this series is convergent. This one is improper integral convergent. Then they have some value, that's the a. So we say convergent. So this infinity series converges, but doesn't mean this value gonna be same. It's not. We don't know. It's not gonna be a. We just know infinity series gonna be converged. We don't have any idea sum of this infinity series. That you have to keep in mind, guys. Okay. So let's see very important infinite integral test. Let's try two integral tests. Let's try first one, guys. First one is when you see series right there, part A, an is 1 over n squared plus 1. Now you're going to find the function, represent this sequence. So fx going to be 1 over x squared plus 1. Then you're going to sketch the graph. You can use online graph calculator or your own graph calculator. You're going to sketch it. So only we're going to consider 1 to infinity. So here is a 1. Look at this graph, this part. This part, fx is positive, continuous, and decreasing. Clearly see it right there. So we're going to check improper integral 1 to infinity 1 over x squared plus 1 dx. Definition of improper integral is limit t approach to infinity 1 over t 1 x squared plus 1 dx. What is the antiderivative 1 over x squared gonna be? Arctangent. So plug in the t value. right? T approach to infinity, arctangent T gonna be pi over 2. Arctangent 1 is pi over 4. This improper integral gonna be equal to pi over 4. Now, conclusion is we're gonna say this infinity series converge. But we're not gonna say some of this series gonna be pi over 4. We don't know. We don't know exactly some of this infinity series. So just we know, one thing we know here, guys, this series is gonna be converged based on integral test. Let's practice more integral tests right here. Its second one is gonna be, guys, here. So an, we're gonna do this second one. An gonna be n over n squared plus 1. Fx gonna be x over x squared plus 1. So you're gonna sketch this graph by using the graphing calculator. You're gonna see this graph looks like this one is. Looks like this. So we want to see this one is going to be 1 right here. Of course, this is decreasing, positive, continuous. So now, evaluate the improper integral where to where 1 to infinity x squared plus 1 dx. Definition of improper integral gonna be x squared plus 1 dx. So this one is limit t approach to infinity. Find the antiderivative. You're gonna use u sub. You're gonna be x squared plus 1. Du gonna be 2x dx. You're gonna change the boundary, or you're gonna find the antiderivative. Then you're gonna plug it back. So ln gonna be 1.5 x squared plus 1. That's gonna be 1 over t. Okay, so now after this, guys, look at this one. So you plug in the t value right here. Limit t approach to infinity. Here is 1 over 2 ln t squared plus 1 minus 1.5 ln 2. So t approach to infinity. This going to infinity, which meaning is diverge. What's the conclusion? This improper integral diverge. So we're gonna say right here, this infinity series diverge. That's you're gonna evaluate this infinity series. Let's do one more example right there, guys, right? So here is an. This time an is ln n over n. So fx gonna be ln x over x. When you sketch this graph right here, guys, looks like this one. So here is the 1. Okay, so this one is gonna be, we're gonna looking for this function, but this one is from here is not decreasing, but here from decreasing. So you don't worry about too much where the function gonna be decreasing. So this one is a positive, decreasing, continuous. Okay, so now we're gonna calculate improper integral of this function, right? Then using the definition of improper integral, then find the antiderivative. You're gonna do u sub, you're gonna be ln x, du gonna be 1 over x. So you're gonna find this limit, this antiderivative. Okay, then what is gonna be? This one is a limit t approach to infinity ln t square minus ln 1. T approach to infinity ln t going to infinity, that's the diverge. So our conclusion is this infinity series is gonna be diverge. All right? Now, I'm gonna introduce a very important series right here, guys. First one is gonna be we call P series. This one is we call P series. This form right here, guys. Here is a summation n equal 1 to infinity 1 over np, 1 over 1p plus 1 over 2p plus 1 over 3p. P is any positive number. P series, P is any positive number. This form we call P series. P is especially 1. We say this is a harmonic series. We prove it. This one is diverge. We prove it beginning of this presentation, right? So this is a P series. Depends on P value. This might be a converge. This might be a diverge. So here is the idea first, guys, right here. P is 1. Then gonna be this harmonic series is diverge. P is between 0 and 1. Also, this one is diverge. But P is greater than 1. This series is gonna be converged. Okay, that's very important P series. Why? I'm gonna explain next slide. We talk about convergence of P series previous slides. P equal greater than 1, guys, first. P is greater than converge. P is between 0 and 1 is diverge. P equal 1 harmonic series diverge too. Where they coming from? Coming from improper integral of P. So previous module, we study improper integral. So this one is, generally speaking here, an is gonna be 1 over mp. So this one change the function fx gonna be 1 over xp. So previous model we studied depends on p value. This improper integral converge, diverge. For example, p equal greater than 1, this improper integral is converged, which meaning is coming from this infinity series gonna be converged. Where p gonna be greater than 1. P is 1, guys, p is 1, let's say p is 1, integral 1 over infinity 1 over x dx, diverge. So we're gonna say this infinity series gonna be diverge. That's a harmonic series, right? Last part, P is between the 0 and 1. That's infinity's improper integral gonna be diverge. So we're gonna say infinity series gonna be diverge. Okay, so P series P equal greater than 1 is converged. Other P value gonna be diverse. So we're gonna practice P series in next slides. Make sure it's this form right here, guys. Look at this. Summation n equal 1 to infinity 1 over mp. This form is a P series. P equal 1 harmonic series. So we know that this P series convergent divergent depend on the p-value. Let's evaluate this infinity series, P series. First, we know the what is p-value right here. First one is, can you see that this one is first one? This one is gonna be p-value gonna be what? This one is 1. This one is a harmonic series. So this one is diverse. P p equal to, second one, this second one is p-value is right here, 1 over n squared, that's p equal to. So this series is gonna be converge. Why? P-value is greater than 1. Let's go third one. What is p-value? an gonna be 1 over square root n, 1 over n, 1.5, square root to n is 1.5, p-value is 1.5, p is less than 1, greater than 0. This series is gonna be diverge. Everyone get the idea about p series? Let's do more practice. Let's see the D series right here. I expand the P series, right? First one is an 1 over n square root n, right? So let's simplify this power. So n square root n times n 1.5. Here is 1 n 3 over 2. So this one is 1 n 3 over 2. What is p-value here? P-value is 3 over 2. So you're going to say, since p-value is 3 over 2 is greater than 1, this series is going to be, first series is going to be converged. You understand that this series is going to be 1 and 3 over 2 converge. Right? Let's go second one. Second one is going to be an is 1 over cube root n. So how can we write it? Cube root n is n, 1 over 3. That's the exponential form. So this one is going to be 1 over n, 1 over 3. What is p-value? P-value is 1 over 3. That's less than 1, greater than 0. So our conclusion is this series is going to be n, 1 over 3, going to be diverge. Guys, make sense this one? Let's do more practice. How about this series? Doesn't look similar from previous example. So first, what you have to do, this little trend is right there, guys. Look at this one. Summation n equal 1 to infinity, square root n over n squared plus 4 over n squared. Okay? Then you're going to simplify each sequence. Summation n equal 1 to infinity, square root n over n squared plus summation n equal 1 go to infinity 4 n squared. Then first one is square root n over n squared. Let's simplify this power exponent. Here is n 1.5. Here is n squared. So how simplify this one is 1.5. 1.5 minus 2, negative 3 over 2. So this one is n, negative 3 over 2. Another way, 1 over n, 3 over 2. So this case, this series, first one, this one, second is right there. So you're going to go back here. Summation n equal 1 to infinity, 1 over n, 3 over 2, plus 4 is out there. Summation n equal 1 to infinity, 1 over n squared. Now, how about this one? This one is p-value is 3 over 2. This is p-value is 2. So both is greater than 1. This is greater than 1. This is greater than 1. This is 1 converge. This is converge. So our conclusion is right here. This series is gonna be converge. Guys, make sense? So you have to simplify power to figure it out. Let's do the next example. Next example is summation n equal 1 to infinity, 1 over n plus 1. So this one is looks like harmonic series, but notation a little different. So I'm going to expand it. This one is 1 over 2, 1 over 3, 1 over 4, 1 over 5. Harmonic series is gonna be, harmonic series is gonna be start here, summation n equal 1 to infinity 1 over n. We know that this is diverge already, but this one is expanded. This one is 1 plus 1 over 2, 1 over 3, 1 over 4. Which one is bigger? This one is bigger, right? This one is, we add one more. So this one is diverge, we already know. Okay? But this form is, even add 1, you subtract 1, still, the other part, this should be diverse. Okay? A little, one term is different, doesn't impact too much, converge, divergent. So this one is whole 1 plus 1 over 2, 1 over 3 is diverse. So this one is add all term except 1, still diverse. Also, we say this is harmonic series. So 1 over 2 term missing doesn't impact the convergence divergent property right here. So this one is part of harmonic series.